Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study the roller follower, how to draw the cam profile of a roller follower having with motion of uniform acceleration and retardation. So let me take a problem. That is, we consider a problem of we have to design a cam. That means we have to draw a cam profile for operating the exhaust valve of an oil engine. For operating the exhaust valve of an oil engine, it is required to give equal uniform acceleration and retardation. Uniform acceleration and retardation during opening and closing of the valve, each of which corresponds to 60 degrees of cam rotation. The valve must remain in the fully open position for 20 degree of cam rotation. This is the dwell position. The lift of the valve is 37.5 millimeters and the least radius of the cam is 40 millimeters. The follower is provided with a roller of radius 20 millimeters and its line of stroke is passing through the axis of the camshaft. So these are the conditions. Here the follower is, the type of follower is a roller follower, and the type of having roller, the motion of a follower is uniform acceleration and retardation. Uniform acceleration and retardation. So these are the two things we have to consider it. And here the valve remains on opening and closing. That means the valve remain opening with the valve open angle is 60 degree and the dwell after opening is 20 degrees. The valve remaining closed, CL, closed angle is 60 degrees. And by default we can have to understand that remaining rest of the angle of the cam rotation that remains in dwell position, that is 60 plus 60, 120 plus 20, 140. So remaining angle, that is 220 degrees, is remaining in dwell position remaining. So now we are going to draw the displacement diagram of the cam, of the displacement diagram for the case of uniform velocity, uniform acceleration, retardation condition. We have to draw this displacement diagram. Now we have to consider the scale. The scale considered here, it is here the displacement diagram is the diagram of cam rotation versus the lift of the follower. So scale on x-axis we consider as 10 degrees equal to 1 centimeter. So how much angle we have to consider it like that? So consider the even number of positions. So even number means that is we have to divide the outstroke angle or valve, the angle of rotation of opening and closing valves with equal even number of divisions. So optimum even number of divisions are considered, or we are going to consider here is 6. So that in relation to that, the 10 degrees equal to 1 centimeter, the theta open equal to 6 centimeters, theta D, that is 2 centimeters, theta close, theta C is 6 centimeters. So we are going to consider these three things and we are going to draw the displacement diagram. So let us start how to draw the displacement diagram. So draw a horizontal line. The length of partitions, that is these parts are theta outstroke, that equal to 60 degree, then theta dwell, that equal to 20 degree, okay, approximately, and we are going to consider it as another portion is theta return, that is 60 degree. And y-axis shows the lift of the follower, The lift of the follower is, what is the angle of the lift of the follower? The lift, that is 37.5 millimeter. This is 37.5 millimeter. So draw this with the help of the scale. Draw vertical lines with equal divisions of both outstroke and return stroke lengths 60 degree. So I'm going to divide this portion to 1, 2, 3, 4, 5, 6 equal divisions. Similarly, divide this return stroke into equal number of divisions. Equal divisions, but it may not be, I'm drawing with a freehand sketch, it may not be straight also, it may be, but equal number of divisions you have to draw. So divide this center line, okay, mark this center line 0, 1, 2, 3, 4, 5, 6. Similarly, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. So divide this vertical line, center line, that is the third vertical line, into 6 number of even number, that is 6 divisions. So here I am going to one, 2, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Similarly, outstroke center line, that is the center line part, into equal divisions. So this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Now what to do? Take the corner of O and join O with O, and 1, you have to join these lines with inclined lines. Similarly, 4 and 5. So intersection 1 is intersection with the 1. This is the point. 2 with equal lines. I'm going to mark this is the 1 and 0 to this 2. Second one. This is the second. This is the third one. 4th intersecting with 4. 5 intersecting with 5 inclination. Join these points with a smooth curve. Okay, it's like a parabola. Then this is the dwell zone. Similarly, join inclination lines with outstroke angle also. The outstroke angle from this corner, you join with this corner. Similarly, with this corner. So 5 dash is intersecting this line here. This is next point. This is next point and next point. So join all these lines with a smooth curve. The point, next point. Now this is the smooth curve. This is a double parabola. So the curve traced in uniform acceleration retardation is the path. This is the displacement curve in uniform acceleration and retardation of the follower is a double parabola. But it is here, why? During outstroke and return stroke, during outstroke here valve remains closed, and return stroke valve remains, during outstroke valve remains open, return stroke valve is closed. Or the angle of rotation at angle of rotation during a particular angle of rotation of the cam, the valve remains open, and also it is closed at particular angle of rotation. At those places, both are uniform acceleration retardation it is following. So that's why the path traced here, the curve which is shown in color, the curve indicates here, the curve indicates the path of a follower during the first 60-degree rotation, and dwell it is 20 degrees, and again it is valve remains closed for the next 60 degrees of rotation. So the curve looks like that. If you use with the geometric instruments, the curve traces like that. It indicates, it shows, the red color indicates the curve traced by uniform is the curve when the follower moves with uniform acceleration and retardation. So in this manner, how we have joined here? We have joined with the help of the joining. The path traced here, this is the way of following of method of following the drawing the displacement diagram when the follower is under uniform acceleration and retardation. Now after drawing this displacement diagram, we have to go for drawing the cam profile. So the follower is here, it is roller follower. The radius of the roller follower is 20 millimeter. Okay, and the minimum radius or least radius of the cam is 40 millimeters. So here it is. In this drawing the displacement diagram, when the follower is moving with uniform acceleration and retardation, the following steps are to be followed. What is the step 1? Consider a scale. On x-axis, that is 10 degrees equal to 1 centimeter equal to 10 degrees equal to 1 centimeter. Then the valve remains open for a 60 degree of rotation. That means the length of AS is here 6 centimeters. Similarly, make it 20 degrees length, and also outside that is valve remains open for the next, here valve remains closed. Valve remains closed for the next 60 degrees of open. What is the condition given here? Remains closed. That is the valve closed angle here. That is the 60 degrees. In a conversion scale, this becomes the length of TP is 6 centimeters. Draw a vertical lines with equal distances of this during valve open angles and valve closed angles. That is, each division indicates the 1 centimeters. Draw vertical lines, that is 0, 1, 2, 3, 4, 5, 6, and 0, 1 dash, 2 dash, 3 dash, 4 dash, and 5 dash, and 6 dash. And draw a line of ASTP with vertical lines, and divide the center line into equal parts, that is equal divisions, 6 equal divisions. Join these lines with equal divisions. Okay, then join these lines with equal divisions. The path traced, and with corner lines you join the center lines, similarly from bottom and from the top. So these intersection points with vertical and inclined lines gives the path locus of the curve when the follower is under uniform acceleration and retardation motion. Same method you follow from out for valve open angle and also valve closed. Then the curve will come. That curve indicates the displacement curve when the follower is under uniform acceleration and retardation. After drawing the curve, let us begin how to draw. Yes, I am going to show you directly. I already mentioned how to draw draw a cam profile when the axis of the follower is passing through the center of the axis of the camshaft. Okay, first step, draw the base circle with a minimum radius of 40 millimeters. Okay, that is the 40 millimeters curve. This is the base circle. After drawing the base circle, draw the axis line. That axis line indicates the center of the axis of the follower is passing through the axis of the camshaft. So this is the point. and take a distance of 20 millimeter, that is the radius, draw a circle that is indicates the roller circle. So this is the point of roller, center of the roller. Now passing through this center, draw another circle. That circle is known as the prime circle. This is the prime circle. Draw the prime circle. So this is our reference line. OA is our reference line. So from that reference line, draw this prime circle, divide with the angle of rotation of valve open and valve close and dual angles. So valve open angle is 60 degree. This is the 60 degree line. Next, valve closed. Valve remain dual for the next 20 degrees of rotation. For the next 20 degrees of rotation. Next, valve remains closed for the next 60 degrees of rotation. From 20 degree become the reference line. Again draw another line, that is so divide the circumference of the prime circle into equal angular divisions, or that is outstroke. That is what valve open 60 degrees. That 60 degree divide into 6. 1, 2, 3, 4, 5, 6 equal divisions. So that means 6 divisions of 60 degree. That means each division 10 degrees equal parts. So similarly, the valve remains closed. That valve closed angle also we have to divide into equal number of divisions. That is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So passing through this, we have to draw a radial lines from the center of base circle through passing through these division lines. Now I am going passing through this. Similarly, another radial line. Okay. Then after that, what we should do? Next, similarly, the return stroke or valve closed angle also draw the lines. So these are the lines on which we have to mark the centers of rotation of the roller. That can be taken from the distance from the displacement diagram. From this 1 to point B. This is the one line, it is the point B. Similarly, 2 to C, the point C. Similarly, 3 to D, 4 to F, 4 to E, 5 to F, and 6 to G. All these things you have to mark. Those are A, B, C, D, E, F, G. Similarly, we have to mark the distances from the displacement diagram. This 5 dash to N. There is a 5 dash to N. This is a 5 dash to N. You can make it from O dash to H. That is the one of the distance. There is O dash. This is O dash to H. This is the line. Next, 1 dash to this point. 1 dash to J. This is 1 dash to J. Point J. And 2 dash to K. 2 dash, this is the 2 dash to K. Next 3 dash to C dash, or 3 dash to C, or 3 dash, that is L point, 3 dash to L. 4 dash to M, this is the 4 dash to M. 5 dash to N, this is the 5 dash to N. These are the centers of roller on which we have to draw a circles. We have to draw the roller circles. Now this is the line. So we have to draw a circle with 20 millimeters radius. Next, this is the C point. Draw another circle. Next, a D dash. This is the D. This is E point. Next, this is F. This is G. And it is H. And it is J. So like that, you join all the circles. You have to draw roller circles with a particular radius, that is 20 millimeter radius of the roller. It may overlap each other, but our focus is only on drawing the rollers with a particular centers. So after finally, we have to draw a curve. Passing through all these circumferences of the rollers, touching the rollers. It should touch, it's not just touching the rollers. So up to here, from here to here, it is a constant, that a base circle radius. This curve is the cam profile. So there are two circles here. Number 1, base circle. Number 2, prime circle. And one more circle, if we consider that the third circle is the roller circle. So these are the steps one has to follow in order to draw the cam profile. When the follower is having a motion of uniform acceleration and retardation, okay, and the type of follower is roller follower. Condition here, very important condition, is the axis of the follower is passing through the axis of the camshaft. So the maximum radius of the cam, what is the maximum radius of the cam? Here it is. What is the maximum? The distance from T to O, we have to measure it. And the prime circle radius is the 60 millimeter and the base circle radius 40 millimeter. So one more important thing is that the prime circle radius is equal to sum of radius of base circle and the radius of roller. So these are the methods one has to follow. An important condition here, Why we have followed here radial lines? Because the axis of the follower is passing through the axis of the camshaft. If it is in the case of offset follower, we have to draw, instead of radial lines, we have to draw offset circle. And the offset circle, we have to tangential lines we have to draw from that offset circle through the prime circle divided divisions. So that is the manner. Now this is a roller follower, and in the case of if it is a knife edge follower, as in the different sessions already mentioned. And one more thing here, why the shape of the curve coming like that? Because both outstroke and return stroke, it is uniform acceleration and retardation. Suppose the same problem, they have given that valve remains open for uniform acceleration and it is closed with the uniform velocity. In such case, how to draw the displacement diagram? So the same displacement diagram, our portion will be, okay, the displacement diagram will be there. We have to draw, the up portion is uniform acceleration, that is the valve is open, this is the portion, this portion is valve open, the valve is closed, remaining 60 degrees of the rotation. So what to do? Draw vertical lines, equal divisions, now here join from this corner, it is the uniform velocity motion. Join, suppose if it is F and it is F dash, join directly. This is curve of a displacement curve. For the cases of, it is the displacement curve. For the cases of during valve remains closed with a motion of uniform acceleration and it is closed with a uniform velocity, then the curve comes like that, of parabola of straight line. So two parabolas, that means during outstroke and return stroke it is uniform acceleration and retardation, but it is the case during return. During return it is the motion of the follower is uniform velocity, and during open or valve closed condition, valve open with uniform acceleration, this is the case. So the displacement diagram will be changed. So but how to consider it? We have to take, during valve open condition, we have to consider these distances. You have to mark these distances on the radial lines on the cam profile. For drawing the cam profile, for return, for outstroke 60 degrees, you follow uniform the portion of the displacement diagram, that is uniform acceleration portion of displacement diagram. And for the return stroke or valve closed angle, that is a 60 degrees, you have to follow these lengths, these displacements. The shape of the cam profile will be changed, will be varied. It won't be same. Because the points are different. Okay. In this manner, we have to, for return stroke, valve remains closed. That means for 60 degrees of cam rotation, we have to follow these vertical distances and mark on the radial lines. And where intersection points, we have to draw a roller follower. After drawing the roller, we have to draw rollers. After drawing the roller circles, we have to join from the curve continuing from out that valve, that is outstroke angle or valve remains open angle through dwell and again continues through valve closed angle, then the shape of the cam becomes entirely different, okay, in comparison with the uniform acceleration and retardation motion of the follower, that shape of the cam profile. So here we consider mainly important is that very important, the axis of the follower is passing through the axis of the camshaft, and the diameter of the roller or the radius of the roller is 20 millimeters. The base circle, the minimum radius, the least radius of the cam is 40 millimeters. Okay, and it is symmetrical. It is cam both symmetrical about, if you keep it in vertical or horizontal, it's a symmetrical cam we observed. Why? The reason behind is that the outstroke or the valve remains closed and open. Those angles remain equal. That's why it became the symmetry. Exactly symmetrical. The symmetrical cam. Okay, this portion, top portion, bottom portion, both are same, equal. Symmetrical cam observed. So if the outstroke angle theta O is not equal to theta return, then the shape of the cam becomes unsymmetrical. Theta O equal to theta R. Theta O equal to the dwell outstroke angle equal to return stroke, or valve remains closed angle equal to valve closed open angle equal to valve closed angle, then the cam profile becomes symmetrical. So is symmetrical. Here the cam came symmetrical. Both top and bottom surface are equal. If you keep vertically, okay. Now one more thing. By default, we consider that the rotation of the cam is in clockwise direction. That's why when it is in clockwise rotation from my side, the roller is moving opposite to that direction. It is climbing here and comes down, climbing and comes down. So we considered by default, if they did not mention, then we have to consider it as a clockwise rotation. So maximum problems, they won't mention the rotation of the cam. If it mentions counterclockwise direction, the left side of the all rollers comes to right side. But the shape of the cam remains the same. The rotation, whatever rotation may be, that means the geometry of the cam is independent of the rotation of the cam. So here, what are the parameters? The geometry of the cam is dependent upon the angle of rotation during outstroke and the angle of rotation dwell, and also angle of rotation during return strokes. If both outstroke and return strokes are equal, then the cam becomes equal, symmetrical cam. And if outstroke angle is not equal to return stroke angle, then the cam profile won't be symmetrical. It is unsymmetrical. So very important. So the shape of the cam, what are the parameters? It will depend. The shape or geometry of the cam is dependent upon angle of outstroke angle, return stroke angle, and dwell angles. And that is the main thing. And also the size of the cam is dependent upon one more thing. Shape of the cam, the size, if you want larger or smaller, it depends upon the minimum base circle radius and the size of the roller follower. If the size of the roller follower and base circle radius are high, the cam profile becomes larger. The profile of the cam becomes big. So these are the certain parameters we studied in this session. Okay, this is what for in the case of offset follower. So as I mentioned before, this is the diagram having during valve open and valve closed with uniform acceleration and retardation. Suppose if one more case study, very important that the valve remains is a valve open during SHM and valve is closed with a simple uniform velocity. Then what happens? So these angles in the place of this portion, it comes as SHM. So draw a line, divide this line horizontal line. Suppose if valve is closed with SHM, valve open with SHM motion, and it is uniform velocity during valve closed time, then valve closed means outstroke angle, it remains straight line, whereas SHM line, then what to do? Divide this simple harmonic SHM, then join the horizontal lines. So join all these points with a curve. So this is SHM curve. So valve open with SHM, valve closed with uniform velocity. So the shape of the displacement diagram looks like this. So we have to follow with the geometric instrument to get the exact dimensions of the displacement diagram. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.